All right, in this part, we are going to learn how to name covalent compounds. In my personal opinion, it is a little bit more easier than how we named ionic compounds because it is less complex and more straightforward. You don't even need to check any ionic charges. You don't need to include any Roman numbers. So different set of rules, but very easy. Let's learn now how to name a covalent molecules. First of all, how do you know which one is a covalent molecule is when you look at the formula. This is how you would know. When you look at the formula, if it doesn't have any metal, which means you have a covalent molecule. So this is how you name a covalent molecule. You name a covalent molecule by dividing the given molecule in two sets. Again, let me just say this before we jump into this. Here, naming a covalent molecules is like a vast subject. It's a huge subject. If you open any organic chemistry book, you see too many rules on how to name a covalent molecule. But what we are trying to do here in this chapter is trying to name the simplest covalent molecules. I guess now I need to take my word back that naming covalent molecules is simpler than ionic molecules. Sorry to disappoint you. What I meant to say is in this chapter, naming a covalent molecules is simpler compared to ionic molecules. Even though it is much more complex, maybe when you take organic chemistry course, you would spend a lot of time on naming covalent molecules in a particular way. But in this chapter, it is easier to name covalent molecules because we name simpler molecules, simpler covalent molecules, okay? So how do you name these simpler covalent molecules is by first dividing the molecule into two parts, one element and another element. So why? Because you're only focusing currently on just binary molecules. What it means is like diatomic molecules. So very simple, right? So you just name the first one as it appears in the periodic table. How convenient, right? Just like if you have carbon, you name it as carbon. If you have nitrogen, you name it as nitrogen. If you have sulfur, you name it as sulfur. Very simple. But the second part, you make a little bit change. Okay, what is the change is name the second element that appears in the formula and change the end to "ide." Okay, that's why how we have this specific way of naming. That's why as a chemist, we want you to write the chemical formula as the same way that everybody does write, because we all kind of rely on that style of writing that molecular formula. Everybody is same, so that name comes out right. What it means is, if you see HCl as like this, and when you need to write HCl in future, and always please write as HCl. Please don't reinvent the wheel and write it as PLH. It looks horrible to me, to my eyes. I cannot even look at it because that is so, well, it's technically right, either way you look at it, but in terms of trying to call it differently, that's so horrible. It makes things confusing. That's why in chemistry, you want to do the same thing similarly because so many people are counting on it. Please do not, reinvent the wheel when you look at something so basic and how we always write the same. Please just follow the same because naming is depending on it. So HCl is going to be named as, first element that you see is hydrogen, second element you see as chlorine. So you don't have to make any changes to hydrogen, but you have to make a change to chlorine as chloride. So it is hydrogen chloride. And why I don't want you to write HCl as ClH is name would change to chlorine hydride, which sounds so horrible to me. It is horrible name. That's why please don't reinvent the wheel. What if you have HI? How do you write that name? You write it as hydrogen and change iodine to iodide. So hydrogen iodide. All right. Now, what if you have multiple of any one of these elements? What if you have more hydrogens, or what if you have more chlorines, right? So in those cases, we are going to use this table to express how many of those extra elements you have in a binary covalent molecule. So what it means is we are going to get familiarized with these Greek prefixes for these many multiple times molecules that are present. When you see examples, it just easily makes sense. For now, just know that mono is for one, and for two, we use di. For three, we use a tri. For four, we use tetra. For five, we use penta. For six, we use hexa. For seven, we use hepta. For eight, we use octa. For nine, we use nona. For 10, we use a deca. Okay. Most of these, for many of you, they are so familiarized by now. Now, let's put them into use. So if you have carbon and oxygen as your molecular formula, first element you just name as it is, and for the second element you change it to ide fashion, right? So carbon oxide. However, if you have, well, the common practice is for the second element, you need to tell if you have just one of them or more than one of them. So because you only have one oxygen, you're saying one oxygen. Only exception that you don't have to use mono is for the first element. You don't have to say that this carbon already had just one. I guess, name looks boring if you say monoxide, if you say monocarbon, monoxide, right? And also looks long and redundant. So to avoid that, we just all commonly agreed upon that if the first element is only one single element, let's just assume that it is already a single element if we don't put any Greek prefix in front of it. So that's what it says, right? That's the common agreement in chemistry. So now you know. So please do not include mono in front of that first element if it is only one element, because name looks boring. Please don't write boring names. So carbon monoxide. And how do I know that CO2 should be called carbon dioxide? Is there is one carbon, so I'll say carbon, and dioxide means there are two oxygens here, so there should be di in front of it. So carbon dioxide. SO2, just like CO2, it should be named as sulfur dioxide. And SO3, sulfur, 3 oxygens, so trioxide. And NO2, nitrogen and 2 oxygens, so dioxide. And 2O5, dinitrogen. See, 2 nitrogens, so you have to include the prefix, and a pentoxide. Okay. Now, sometimes you may notice that we're not exactly using the Greek prefixes. Only exceptions is that, to make the name easy to pronounce, whenever the Greek prefix name ends with O or A, we just, omit them. We don't include them, especially if you have to name them in front of oxide. Let's see if you have. Oh, sorry. Let me get a pen. Let's see if you have SiO4. So silicon tetraoxide. So, name looks not rhythmic, right? So we change it to silicon tetroxide. We exclude the last letter A from tetra. And here is example penta. So N2O5. So it should be dinitrogen pentaoxide. Name looks longer. So to make it easier, we say dinitrogen pentoxide. We just exclude those. No big deal, but just to make things better for the communication purpose. So let's name this compound. It is asking us to name molecule NF3 and N2O4. Let's see what names we come up with. nitrogen there is having only one nitrogen, which means you don't have to use anything in front of the nitrogen. And fluorine are three of them, so name should be nitrogen trifluoride. And the second molecule, N2O4, there are two nitrogens, which means you should be using the Greek prefix di in front of nitrogen, and the Greek prefix in front of oxygen should be tetra, so it should be dinitrogen tetroxide, right? Let's look into how do you come up with a chemical formula if you know the name of a binary molecule. One example here you see is sulfur tetrafluoride. Sulfur doesn't have any Greek prefix in front of it, which means there should be one single sulfur. And it said a tetra in front of fluoride, which means there are four fluorines. Okay, that is SO4. And tetraphosphorus decasulfide, it is saying that there are four phosphorus elements and 10 sulfur elements. So P4S10. This is how you would identify the molecular formula using the name. Now, I'm just going to take you to name different species that are not going to follow what we just discussed so far. They were just, special kind of natured elements. So we just reserved common names, kind of. They were so popular with their common names, so we just use them instead of, using these similar names. So those are, so what is the good example? I want to come up with new example, but that might make things complicated. So let's stick to the script. Excuse me. So these are used only for specific molecules that are so popular with its common name. Oh, here is my common example, so I'm not so off. So molecules that you're looking at are so popular by their common names. So you don't want to name them with the binary names that we use so far, because it looks odd. Because you don't want to say, can you please give me dihydrogen monoxide whenever you're thirsty, right? That makes things harder. Are you looking weird to common people? Maybe a chemist will understand, but common people think that you might be asking something they don't have. So don't do that. So these are the molecules that are so popular. B2H6 is popular as diborane, and SiH4 is popular as silane, and NH3 is popular as ammonia. PH3 is popular as phosphine, H2O is popular as water, H3S is popular as hydrogen sulfide. Some common names. Sometimes in chemistry, you just need to have a memory of what it is called, because that's how people remember. So many molecules, some came through cracks and they got popular on their own. So that's how we just need to remember them. No shortcut here. All right. So another type of molecules that are popular, that became popular to their own category, is based on its chemical properties. And also, whenever I explain this, and also I say that, having included acid at the end of acid molecules is for the sake of our safety, I would say. You just want to let people know that you have an acid there. You don't want people to touch them casually. Your name should be scary if you have an acid. So these molecules that contains hydrogens that are acidic in property has the tagline acid, has a specific name style, which is hard to miss, and for a good reason, because people will immediately get alert and don't mess with the acid that they shouldn't in the first place. So whenever you have a binary compound, but if your hydrogen is acidic, this is how you would name them. Don't worry too much about how to identify acidic molecules. I'm not going to give you so many acidic variations in this term. We spend lots of time in Chem 223 later in the year, but for now, just know this one. when hydrogen is connected to any one of the halogen, like chlorine, uh, bromine, or iodine, it results in acidic hydrogen. That's all you need to know. So any combination of hydrogen to halogen is an acid. So you need to name them differently. How do you name them? Is you change the first element, the hydrogen, to hydro by removing the gen from hydrogen, and you change the second element, ide fashion, to ic acid. So instead of saying hydrogen chloride, which looks less scary, you say hydrochloric acid. Definitely scary name. So people know that it's an acid for sure. Otherwise, people, may or may not know that it's an acid. That's why we name these as hydrochloric acid. In a similar fashion, we name HF as hydrofluoric acid, HBr as hydrobromic acid, HI as hydroiodic acid, and HCN as hydrocyanic acid. So acids are named specially because they were special and scary. All right, so here from this part, I would say you can rest a little bit because I do not expect you to remember the names of organic compounds. I expect you to get familiarized with them, but I'm not going to beat you if you don't remember them. Previous ones, so far that we discussed, I need you to remember. I need you to be able to write those names. But these, I just need you to know and know what to expect in future. Organic compounds are what people discuss in organic chemistry, and majority of you, or at least I would say majority of you, at least few of you, would need to take organic chemistry in future. If you do take, these are the molecules that come across to you, which means anyway you're going to learn them in future, so you don't have to worry about them right away. And if you're not going to take organic chemistry in future, not knowing these names physically, not going to hurt you much. So just get familiarized with them and don't beat them yourselves to know this. So whenever you have organic compounds come up with their own set of rules how to name a compound. And here I'm going to show you how to name those compounds. Organic compounds are compounds that contains mainly carbons, at least one carbon. It is the basic definition of an organic compound is it should contain at least one carbon. So far, the molecules that we discuss are not really organic compounds. You might have one or two, but majority of them are inorganic compounds, like HCl doesn't have carbon, HF doesn't have carbon, N2O5 doesn't have carbon, right? Those are all inorganic compounds. To be qualified as organic compound, you need to have one carbon. So one of the popular type of organic compound is hydrocarbon. Just like name suggests, it contains only carbons and hydrogens. One of the simplest branch of hydrocarbon is alkanes. I'm just going to show you the common, most popular alkanes, few of them. Some of them you might come across in daily life. You would have here the name methane, when you refill the gasoline, or propane, or pentane. So for one carbon, we call it as methane. If you have two carbons, call it as ethane. If you have 3 carbons and 8 hydrogens, propane. If you have 4 carbons and 10 hydrogens, butane. For 5 carbons in the ratio of hydrogens, call it as pentane. Similarly, hexane for 6, heptane for 7 carbons, octane for 8 carbons, nonane for 9 carbons, and decane for 10 carbons. If you remember, it's great. If you don't remember, again, I am not going to beat you. Now, let's see what do we have here. These are, again, something that you should know, great, but if you don't know, it's not going to hurt you right away. These are called functional groups. These are, Organic chemistry is categorized in branches. Alkene is one branch, and there are many other branches. One of those branches is alcohol, like for every carbon, hydrogen, well, I shouldn't say every. So you would have, along with your carbon, you would have at least one OH. If you do that, it's called alcohol. If you have CHO as a fixed structure, it's called aldehyde. If you have COOH as your fixed structure, it's called carboxylic acid. If you have NH2 as your fixed structure, it's called amine. That's all for this part of naming covalent molecules. I'll see you in another part. Please review part 5 and part 6 and get really familiarize how to name covalent molecules so that we can move on to do awesome things in future in this term and in next term.